Okay guys, I wanted to make a video or two of this board in use before I send it off to Knowles. So the board's hooked up with 24 volt power supply going to drive the MOSFETs and the coils, and I've got 5 volts coming in here to drive the Raspberry Pi Pico and the switches and the opto-isolators and the LED indicators that are on the board. I've connected up these stern flipper assemblies. So these have got FL23 600 coils in them. They're low impedance coils. I think I measured that they had about 2 ohms impedance, so they can draw a lot of current. I've shorted out the hold coil on these, so the hold coil is not part of the operation. All the hold will be done by the board. Okay, so the first thing I have to do is set the dip switches for this combination of 24 volts and the stern coils, and that's binary 5. So I set this to that. Okay, and then reboot the board. Okay, so that means it's rebooted. And now, let's see, I'll press the flipper button. And that's now in hold mode, 24 volts. It's drawing 0.29 amps. Do the other one. You can see on the indicator light that when you initially press the flipper button, it's bright immediately, and then the intensity of the light diminishes after 60 milliseconds in this case, because it's gone into pulse width mode. Now, if you're using end of stroke buttons, these are the end of stroke buttons here and here. So the idea with this is that, let's say you had a flipper in hold mode, and then something like a multi-ball landed on the flipper and pushed the flipper back so that it hit the end of stroke switch. Then the end of stroke switch will give the coil a bit more of a kick. So I'll just hit the end of stroke switch now. You can see the current went right up to 6 amps there. So that should have been enough to force any ball away and get it back into hold mode again. So when I touch the coil's completely cool, which is good, and I turn off the power supply and touch the MOSFETs. The MOSFETs are perfectly cool too, so that's good. I think that's about it.